Page 18. We're going to go over that concept of what domain and range are. Okay? So the two key words at the top of your guys' paper, domain, range. Okay, so domain and range. Obviously, domain, it clearly states it's the x value. And range clearly means the y value. So you guys have graphed linear before. You can graph a linear, you know how to. We've graphed a quadratic before. We know how to do that as well. So we're going to give you a couple different functions here that are not of the quadratic or the linear functions. They're going to look different. Okay. First off, in this first one, what are these things? Yes, it's close. It doesn't just give you a value. Okay, and I'm going to drop down to the bottom of the page because we have a little bit more room down there. When you see these bars, they're not ones. This is the symbol for absolute value. Okay, yeah, you had an idea, Rainisha, of what it was. Okay, now we can specifically get these in the calculator. Now, most kids hopefully would remember the one button that you guys will use on this calculator besides the graphing buttons is this button right here. We used it before, and we're going to keep using it, is the math button. When in doubt, hit the math button if you don't know how to get to something. Unless it's graphing. All the graphing keys are here. So to get this absolute value sign, you would use your math button.
What page is this on?
18.
Okay. Okay, so I'm going to touch my math button. Okay? It's not one of these. I can't see it. So what does that mean? We have other categories at the top of our calculator. Okay, so right now what I'm going to do is I'm going to tab to the right. So tab right, and you can see it. So when you hit the right arrow key on the calculator, you will see the first one underneath number 1 says ABS. That is absolute value. Now if I hit enter, this is an old model calculator. How do I know I have the older model calculator? Do all of you guys see ABS parentheses on your calculators? Or do you see something different?
I see the little one.
Okay, so on an older calculator, it'll give you ABS parenthesis. But if you have a new graphing calculator, you will see this, where they actually use the absolute value bars. Okay. So now on the Regents exam, if you get there and you are uncomfortable with the calculator that you are using because it's giving you something you haven't seen before, you will put your hand up and you can ask for a new calculator. And we will give you a different calculator. We try to make sure almost all of them for the Regents exam, though, are the up-to-date versions, not the older versions. Okay, so that's how you would put the absolute value into your calculator. Okay, so I'm going to continue to use the old one. There's not much of a difference. It does the same thing. Okay, so I'm going to go back up to this problem now. And if they want me to graph this, where should I be at as far as the graphing calculator goes? If I need to graph this, which button will I push? Oh, we can't graph yet. If I hit graph, I'm going to get this. I need to go to y equals first. Okay? Then I type this in. Now, most kids' biggest mistake, They're going to forget the negative 2. So negative 2. Now I need to put those bars in.
I was just down there.
All right, so then yes, you would hit the math key. Hit the right over to get to the numbers. And then press enter. Now for me, x plus 3. For you guys would tab right if you have the older version. For me, I have to close my parenthesis. You guys would just hit the right key to get out of the bars, where I actually have to close mine. Okay. Now, in general, you're going to want to get an idea of what this thing is going to look like, so I'm going to hit graph. Oh, I got a window range issue. Hold on. There we go. What does it look like? It looks like a triangle. We call it a V-shaped. So when you graph an absolute value, and again, this is an absolute value. This is V-shaped. Okay, that's V-shaped. So when I go to graph this, that's exactly what's going to happen. I want it to be V-shaped. So where do you go to get numbers to graph? Can I just sketch it, by the way? Can I just go be like, oh, that's what it looks like? No. No, if you do that, you get 0. Okay, so second, graph will get you to your table of values. So I'm going to... Uh-huh. Okay. Now, why did I choose from negative 6 to 0? Any ideas of why I made sure my screen was negative 6 to 0? See this point right here? Notice what's above it and what's below it. Just like a quadratic, an absolute value has a turning point. So that's my most important point, is negative 3, 0. Because on either side, to the left and to the right of that point, these numbers are all the same. So I'm going to graph a few of these. I'm going to graph negative 4, or negative 5, negative 4. Okay, so negative 4, negative 2. That's going to be the same thing on the other side. Okay, then I'm going to go down to negative 4. Okay, so I'm just plotting the coordinates, negative 1, negative 4, and they match. 0, negative 6, and negative 6, negative 6. They're somewhat easy to graph because if you notice, they're in the same position on both sides. Okay. What this gives me is what I should have, which is a nice V shape. Let me grab a... It continues. And it continues. Yes. The real question that's coming next is, what is the domain and what is the range? Now, question, what's domain again? X values. Okay, so if we took a look, even in our table, if we took a look at this, are there any X values that I can't use? No, I can keep going and going and going, right? Yeah. And I can go in the negative direction. Now let's look at these X values again. Now if I keep going into the positive direction, am I ever going to stop? Nope, I'm not. So if I can keep going and I don't get any type of error message or anything like that, then I'm going to keep going. And how do I know I'm going to keep going? There's an arrow on both sides. That means it's going to keep going. Now X values, do they run left and right or up and down? Left and right. This is going to keep going to the left, and this is going to keep going to the right. So where do I stop? Or what can I use to represent it? Not quite a point. Infinity is what I'm looking for. We're going to use the symbol infinity. Infinity means on and on and on and on. Yes, the sideways 8. So our domain really goes from a negative infinity to a positive infinity. Now, most of the time, you'll see it written in an interval notation. Okay, so if I'm talking about domain, what should be right here? X.
Yeah, good try.
And then this is going to be both less than symbols. Because can you ever reach infinity? Can you be equal to infinity or no? No. So we cannot use the equal to symbols here. Okay. Now, what's range? They're y values. So let's look at our y values here. And I'm going to go back up for that reason of where I had it to right about here. Okay, tell me what you notice about your y values. Okay, what's happening from here to here to here to here? They go in which direction? Okay, we can see it on here. Here's the -6, -6. I'm going where? I'm going up. And then, what happened? I stopped going up. Now I'm going to start going back down. Okay, so what I want to take a look at is the idea of the y's. Okay, so on this graph as we're looking at it, it went up, 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 and then it stopped going up, and then it did what? Started going back down. Okay, so when we're working on interval notations, generally this is your low and this is your high number. Okay, so looking at this graph, does it have a low or does it have a high? When we look at domain and range, we generally would look at the lowest value we're going to go to and the highest value we're going to go to. Now, when we were looking at this one, do we have a low or a high point? This is a high point, but it's only high for the y-axis. This is only a high for the y-axis, okay? And yes, you're right, it's at 0. The highest that the y numbers go are 0. But what's the lowest then? The arrows represent what? That they're going to keep going down to negative infinity. So my low here would be negative infinity with a high of 0. And if I'm talking about range, what letter should be in the middle? Y should be here. Okay. Because range means y values. But notice here I put an equal to symbol. Okay, why? Because we can equal 0, but we cannot equal to negative infinity. Okay, so the next graph has another new symbol. Okay, I'm going to move my paper down so I can get it down here. We see this. That's the symbol that I'm talking about. This is a symbol for cube root. This one won't be square. It's actually cube because of the 3. Okay, I need to get this on my calculator. What button will I push?
It's right there. Guys, what button will she push?
Told you guys, the other buttons besides the graph buttons is what? Is math. That's the only other button we've been using. Is math.
I'm the only one. Same here.
You mean the only one on your cell phone right now? Yep, you are. You're the only one on your cell phone. So now, if we do math, let me turn my calculator back on. Okay, if I do the math button, do you see the cube root on the main screen?
No.
It's there.
Oh, it is there.
What number is it?
Oh.
This is the symbol for cube root. So all I have to do is hit enter. Okay?
Over and then enter.
I can't go over and then enter. I'm on 4. I'm highlighted on 4, so I don't want to hit over. So I just hit enter. So now you'll see that it actually pops up. So in the math one, it really is number 4 for your cube root. So all you have to do is then hit enter.
All right, G. Cube
Okay.
root. Cube root.
Now remember, on this screen, you're only able to type in numbers. You cannot type in letters here. That's the reason why when we're given this one, we need to be in y equals. So I'm going to clear that out. Okay, and again, the cube root is underneath your math key. And then you go down to number 4
Or enter.
and hit enter. Now, mind you, I have the old calculator. Your guys' should show up as a box, where mine shows up as parentheses. What's the only thing I want underneath that cube root? What's the only thing I want underneath the cube root?
X.
Just the x. So when I type in x, I need to close mine.
What you do if you have an old calculator?
I have the old calculator. I'm showing you, Dwayne.
All right.
Okay? I close mine with a parenthesis. You guys with the newer calculators will tab right to get out from underneath the radical. Okay, now as I finish typing this, I just type in -4. Okay, I want to see what the graph looks like. So I'm going to hit graph. It's a newer looking one. This is what a cube root function looks like. Now, but this has something new. It has extra added to it. What does it mean for -8 less than or equal to x less than or equal to 8? What is it trying to tell you to use? First off, what are they trying to tell you to use? X's that are from where to where? So right there, that's your domain. Your domain, they're trying to tell you only go from -8 to +8. So in your table, that's only what we're going to use. I'm going to use from -8. And at -8, you notice the y is a what compared to at -7? This one is a
Negative.
whole number.
Oh.
And all of the remaining things are all what? They're all decimals. So most kids get confused. You don't graph decimals. I'm just going to look for the whole number. So that's the first one I'm going to graph. -8, -6. -8.
What do we call them? Irrational? Rational? No, rational.
That's a good question. Is it irrational or rational?
It's irrational, right?
Yes. It's irrational if they keep going. Now, in these calculators, if I actually go over to that y value, you can see this rounded it up here. But down here, you can see the whole entire thing, and you can clearly see that is definitely irrational. Continuing. Now, we'll keep scrolling up towards +8 to see if there's any more whole numbers. So keep scrolling by just hitting the down arrow key. Oh, look, there's one. -1, -5. So I'm going to graph -1, 2, 3, 4, 5. There's one. Okay, I'm going to graph 0, -4. I'm going to graph 1, -3. And then I'm going to see if there's any more. Decimal, decimal. Oh, Told me to stop at 8. I'm not going to go past 8, but I did get a whole number of -2. So all the way to 8 is -2. Now the biggest mistake kids could do is try to connect these with straight lines. They're going to try to go from here to there, but that's not what it looked like. It looks like kind of like a what? Close to a staircase, but if you look,
It kind of does like that.
these are actually like more of a curve. So it's kind of like this. It kind of looks like it went up and then it came back. So it's supposed to look more like a curve than anything. Now I need my white out because I just made a mistake.
It's alright.
Yeah,
Mine's
it's
is
fine.
so pretty.
What's my mistake?
You did it wrong, miss.
How?
You just did it wrong. But it's fine, miss. We all make
drew
mistakes in life.
No one can find my mistake?
Yeah, your mistake is.
But you straighten out the line. You
What
gotta
are
straighten
you
out the
talking about?
line.
That's exactly what I said.
Yep, right there, miss.
What am I doing?
Just.
Straightening it. Oh, you going
Arrows.
past the point.
I went past the points. Am I supposed to?
No.
No,
Why not?
I went past mine too.
Why can't you go past your points?
Because it stopped at, it's where it started and where it
Because
stopped.
that infinity thing again.
Yeah, no, we don't have an infinity. There is no infinity. They told you where to start and they told you where to stop. Okay, so that was clearly my domain, but what's my range then?
The range is gonna be.
Okay, these represented the what values? The x value. So what I need is the what value? The y value. So what I need is the y values that match at these 2 points. Okay? I need y values for range. So all I'm going to do is I'm going to use the y value from this point because it stopped there, started there,
Can't see that.
and I'm going to use the.
I know that's -2,
This is -2.
I think, or -3. I can't see it here.
What's this one? Well, if you had a graphing calculator and doing it with me, you could easily use your graphing calculator to find them.
You say that's 2, that's about, what, 6?
Wait, what?
So I'm going to use my graphing calculator to find the exact y value that matches that start of the x value, which is -6.
I said that. How smart can I be?
Okay, so I'm going to just start this next one with you guys, and then I want you guys to try to finish some of it.
Every time you say that, it ends bad.
Yeah, I know kids don't always work. Okay, so I'm going to go here, and I'm going to type this in, 3 parentheses. Anybody remember how to get a fraction in your calculator?
Yes.
How?
Math.
Nope. Nope. Well, you can use division, yes. But how do you get a true fraction? Do you guys remember? To get that true fraction in your calculator, you would do alpha y equals. Then you want 1 that stands for numerator over denominator. So we do alpha y equals. I want the true numerator denominator. So I do 1 divided by 2 and then close that parenthesis. Now, how do you get the x to go up to the top? Which key is that? There's a button on your calculator that they call a caret key.
Carry key. I know that.
Okay?
I can tell you where it's at.
This is your caret key. Okay, so to get that power up there, you'll want to type this button, which is right above your division key.
I'm guessing it's power 3.
So I'm going to raise it to the x, tab right to bring it back down.
Where you said that button was?
It's right here above your division key. Okay, so now I can go, I'm going to look straight at the graph to see what it looks like. Oh, Hold on one second, I gotta fix mine.
I don't see nothing.
Yeah, you couldn't see it on mine. I had to fix it. Somebody played with the screen. This is what it looks like. It comes down, and that's about it. Okay, so I can't just sketch this, and nor would I. So go to your table and get your values. Now, when you do that alpha y equals, the calculator is going to put it in fraction form for you. So if you notice at 1, it says 3/2. Okay? It's going to give it to you in fraction form, but I am going to get some of the nicer values by going up. Okay. 12 is not going to fit on this graph. It only goes a high of 10.
Hey, mine don't look like that.
So -1, 6. Did yours look like my screen? 0, 3, 1, 3/2, 2, 3/4. So I'm just going to get a few points enough to be able to graph them. We can graph some of the decimals, but not all of them. Right, so I'm going to graph -1, 6, -1, 1, 2, 3, 4, 5, 6, 0, 3, 0, 1, 2, 3. Now, quick question. What is 3/2 as a decimal? What's this as a decimal? So I can quit that out and I can do 3 divided by 2. What is it really as a decimal? 1.5. Then I can do the other one, 3 divided by 4.
Wait, where you get that?
I had gotten these ones from your table.
No, I'm talking about that first point.
This one?
First point on the graph.
Oh, that's -1 up to 6. The second point is 0, 3. Okay, so 1, 1.5. Okay, so I'm going to go over 1 and up 1.5. It's right in the middle. Then I'm going to go over 2 and up 0.75. Now 0.75 is not all the way to 1, but it's most of the way to 1. So if I go over to 2 and I go up 0.75, I'm really, really close to that line, but I'm not on it. So now I'm kind of getting a graph of what this looked like. Yes, at 1 it's a decimal, and at 2 it's a decimal, but they're not a ridiculous decimal. Even 3, if I was to graph 3 and 3/8, and I do 3 divided by 8, I get 0.25, or 3.75. So I could kind of graph 3. It's going to get even closer to the line. And then I just graph what it looks like now here. I have enough points to sketch this. So I can start kind of up here, come down to this point, go out to these points, and then go this way. Notice you can't see much more after here, because it's getting closer and closer and closer and closer to the x-axis, but it's not touching it. It's like your siblings. If they put their finger really, really close and they're like, I'm not touching you, I'm not touching you, I'm not touching you, and they're not. But they're close. Okay, but you do need arrows, because this function does not tell you where to start or stop, so you need arrows.
What does that tell you guys when we need arrows? Infinity, right? Yeah. Okay.
Yes, to infinity and beyond. Okay. Now, your domain. What are domains again?
X values.
Your x's. Now, with these arrows, this one's going to keep going to the left, and this one's going to keep going to the right. Is it going to stop?
No.
No. So we would use negative infinity to positive infinity.
Oh, yes, it is. What's on the left side? Almost got me there.
Now the range. Remember, range are y values, and we talk about range as an up and down. Will this thing keep going up and up and up and up and up and up?
Yes.
Yes. So my high is never going to stop.
So you put infinity?
So I put infinity, and if anybody picks up on my mistake in the first one, I made a mistake here. Anybody find it? Before
You know, stick where?
in this,
What you ain't put? You put
left hand in front of the
negative?
to the right.
huh?
See it?
You put a negative?
It's X. and
Supposed
then
to be.
less than.
What?
Less than equal to. Is that it or no?
What?
It's X and then a less than equal to.
Yeah, I have an x and a less than or equal to. Yep, that's good. But I still have a
The
mistake
negative
somewhere.
In front of the infinity?
This negative is supposed to be there.
Oh, you ain't putting another negative?
Oh, no equal to.
Why?
Oh, because they not. Oh, because you can't equal to.
You cannot equal to infinity, so that was a mistake. All right, but does this keep going down, 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 down? No, where's it not going to go past? We're looking at this one, and I need the low. It's not going to go past 0. Look at you, Dwayne. It's not going to go past 0. So that means 0 is my lowest because I'm not going to go past it. Now, can I equal 0 or not? It's over. Well, let's check the table.
Yeah, you can't equal to 0.
Can I ever get a 0 in this column?
Yes. Oh, in that column?
Yep.
Yeah?
Did I reach 0?
No. Wait, in which column? The Y column?
The Y column. Did I reach 0 yet?
No.
Nope, you're not going to reach it.
You're right. I'm not going to reach it. What does that mean? Because I'm not going to go past it, which means I'm getting very close. It's like your sister trying to touch. I'm not touching you, but she get closer and closer and closer, but she doesn't ever touch you. It's never going to touch it, so we're going to use a less than symbol. So again, for some of you guys, this graphing is a review. Some of you guys have probably already forgotten it by now, but this is just a review. Okay, so there's 2 more questions on the bottom of your page that I'm going to have you guys try. And then tomorrow we'll talk about like more of the piecewise functions, and we'll do some graphing of some inequalities and all that other stuff. Okay, so I'm going to stop my video here.